Hello, it's Scott Manley here, and today I would like to talk to you about Elite Dangerous. Elite Dangerous is the game with probably the most accurate rendition of the Milky Way yet. It features 400 billion stars, many of them of course generated procedurally, but about 150,000 or thereabouts come from actual star catalogues, and that presents an interesting question of how all these things are named, because there are stories behind all 150,000 or thereabouts of these objects. Now, I'm obviously sitting at Sol right now. That's not a real star name, but it is what we would like to refer to our star as. But if you look around, we have a lot of familiar names there. We have Alpha Centauri, right? We've probably heard of that one. We've got things like Barnard's Star, Procyon, Luyten's Star. We have Sirius right there. And all of these star names, there's a reason behind them. There's a little bit of history, and it's worth going over this and explaining what these strange combinations of letters and numbers actually mean and what they constitute, right? We have down here, we see Wise 08550714. What the heck is that, I hear you ask? We see Groombridge 34, Kruger 60, 61 Cygni, LHS 380, YZ Canis Minoris, actually. Yeah, so let's start talking about these, and let's start out with the obvious ones. Sirius is, of course, a traditional name that dates, I believe, from Greek times or perhaps earlier. It's the brightest star in the sky and obviously has a lot of significance. But many of the other named stars have names that have come from much later. Now, Ashinar is a name which actually comes from Arabic. Medieval astronomers, basically, they came up with they looked at the constellations and they would name stars according to what they represented. Things such as like the knee, the shoulder, or in the case of Ashinar, the river's end. Now, the actual original name was Achernar, but this is actually a pretty common misspelling, and it turns out that many of the Arabic names were either mispronounced, mistranslated by scholars in Europe who didn't quite understand it. So what we have is a kind of bastardized version of the Arabic culture or the Arabic set of names. Now, Polaris is an interesting one because it has had quite a lot of different names. Now, the name Polaris itself dates from about the 17th century, but before that it's been called Cynosura for the dog's tail. And a little later on it was called the Lodestar. If you look in different cultures, many of them have different names for it. I'm also going to point out, by the way, that the distance of 432 light years comes from the Hipparcos catalogue, and recent research has suggested that it may actually only be about 300 light years away. It's the closest Cepheid variable to Earth, so knowing the exact distance to Polaris is pretty important. Anyway, moving on. Now, if you are a member of the Hutton Orbital Truckers, then you are probably intimately familiar with Alpha Centauri, but you may not know where the name came from. Well, this is what we would call a Bayer designation, after Johann Bayer, who in 1603 published the definitive catalogue of the stars for his era. What he did was he published the brightest stars in all the constellations, and he labelled the stars in order of brightness, with Alpha being the brightest, Beta being the second brightest, then there was Gamma, Delta, Epsilon, so on and so forth. When he ran out of Greek letters, he would use lowercase Latin letters, A, B, C, and D, etc. And after that, he used uppercase Latin letters. That would be capital A and so on and so forth. So Alpha Centauri represents the brightest star in the constellation of Centaurus. Epsilon Eridani, which you can see down there, that would be the fifth brightest star in the constellation of Eridani. See, this is a very simple and very practical, very organized way of labeling the stars. Now, 61 Cygni, this is an example of the Flamsteed designation. Now, John Flamsteed was working in the early 1700s, and he put together a catalogue of about 2,500 stars, and he numbered the stars based upon the increasing right ascension. Funnily enough, His catalogue was kind of borrowed, or it was published early by Edmund Halley and Isaac Newton without his approval. And they included these numbers. But when he actually published the book, his catalogue, these numbers were apparently removed. So they were later re-added by Lalande later on, but yeah, still Flamsteed designations if you see these numbers. Now, John Flamsteed's catalogue only covered the northern hemisphere. For stars in the southern hemisphere, it would have to wait almost a century for Benjamin Gould to do the same thing. Again, numbering stars in order of increasing right ascension. To differentiate them from the Flamsteed numbers, they put this G in there, so it would be 33 G Canis Majoris. That's obviously from the big dog. Now, it's not entirely uncommon to see a combination of both Flamsteed numbers and Bayer designations in the same star. For example, 31 Beta Leonis Minoris. That makes things totally clear. Now, if you've been paying attention, you might think that R Canis Majoris is just another Bayer designation, but you would be wrong. In the 19th century, they started discovering that some stars changed in brightness. These variable stars were thought to be important enough that they should get designations. The only problem was that Bayer had gone and used up all the Greek letters, all the lowercase Latin letters, and most of the uppercase Latin letters up until Q. So some bright spark thought, well, let's just call them R constellation names. So this is the first variable star within Canis Majoris. But as time went on, they found more and more variable stars. They ran out of letters in the Latin alphabet, and so they started doubling up with the letters, and that's how you get to VY Canis Majoris, at one point the largest known star. While it no longer claims that title, it is pretty darn big, and it is a variable star. So VY Canis Majoris is a 2-letter variable star code. After 334 combination of Latin characters, they ran out and they decided to just switch to V followed by a number, so V350. Canis Majoris is the 350th variable star discovered inside the Great Dog. Okay, so the next group of designations tends to be named after not necessarily discoverers, but cataloguers. Basically astronomers that put together catalogues. We have Lacaille 8760, named after Nicolas Louis de Lacaille, who published a catalogue of a number of stars in the 1700s. Lalande 21185 was part of a catalogue by Jérôme Lalande that was published in the early 1800s, which included something like almost 50,000 stars which had been catalogued visually. Groombridge 1618 was part of Stephen Groombridge's catalogue of circumpolar stars, first published in 1838 after his death. Friedrich Georg Wilhelm von Struve published a catalogue of binary stars, of which Struve 1321 was part of it. Wolf 359 was, well, I guess discovered by Max Wolf. Max Wolf applied photographic techniques to stars, and he was able to discern a number of objects which had high proper motion. So he catalogued these, and Wolf 359 was one of them. As it happens, high proper motion tends to indicate that a star is close to the observer, so Wolf 359 is one of the closest stars to Earth, but it is just one of many in the Wolf catalogue. Now, Ross 154 was first catalogued by Frank Elmore Ross. He was the successor to E. E. Barnard of Barnard's star fame. Barnard's star, by the way, is the star with the highest proper motion of any star because it's nearby and moving very fast. So, Frank Elmore Ross inherited a number of photographic plates from E. E. Barnard, and he decided to go back and make another set of plates and compare them. Now, from this he was able to find a number of objects which had a lot of variability and had high proper motion, and so he catalogued these, and Ross 154 is a fine example. Now, Gliese 1115 is part of Wilhelm Gliese's catalogue of nearby stars. What he did was he numbered the stars in terms of distance. This did of course mean that the Gliese names coincided with many existing names, so they're not really used unless they happen to have been identified and didn't have an interesting name previously. So Gliese 1115 is one such example of a nearby star that wasn't really noticed until it turned up in this guy's catalogue. Now, I already mentioned Barnard's star, which was identified by E. Barnard because of its anomalously high proper motion. Well, similarly we have Luyten's star, which was named after Jacob Luyten, who again discovered a star with a very high proper motion. There's Jacobus Captain's star. Again, very high proper motion, and most interestingly we have Teegarden's star, which is only 12.5 light years from Earth, and yet wasn't discovered until 2003 by Bonnard J. Teegarden. That makes it the most recent star to be given a name, or named after an astronomer. You cannot name stars after yourself, pretty much. It has to come down to the other people in the field deciding that this discovery is really cool, and consistently referring to it as your star in all the literature. Now, Luyten's star is also interesting because it is one of many stars with coming from different catalogues created by Luyten. For example, Luyten 143-23, LAW13 from the Luyten Atlas of White Dwarfs, L168711 from the Luyten Bruce Proper Motion Survey, LDS 1503, the Luyten Double Star Catalogue, LP 1-85 from the Luyten Palomar Survey, LPM 101 from the Luyten Proper Motion Catalogue, LHS 1050, the Luyten Half Second. These are stars which exhibit proper motion of greater than half an arc second per year. LFT 1061, Luyten 5/10. I'm not sure why that's different from half an arc second, but they are separate catalogues. LTT, the Luyten 2/10, for even smaller proper motions. NLTT 10055, the new Luyten 2/10 catalogue, because the first one wasn't exhaustive enough. Now at this point we really do end up going into kind of anonymous catalogues, a lot of acronyms and stuff, so I'm just going to go through these in approximate alphabetical order. So here we have 2 mass and a code number. This is from the 2 micron all sky survey. That's basically an infrared sky survey. WISE 01464234. So this is from the Wide Field Infrared Survey Explorer. That's a satellite that's mapped the whole sky in infrared over 1 year. ACE plus 2637030 from the Astrographic Catalogue, ADS 10035 from the Aitken Double Star Catalogue, AG 011940 Astronomische Gesellschaft something, I don't know, it's some sort of European one. BD plus 022116. Well, this is a hard one because it's actually reference to an exhaustive survey by a German observatory, the Bonn Observatory, from in the late 19th century. I think it's the Bonner Durchmusterung, and I probably brutally murdered that word. But this is an interesting one because those numbers actually make some degree of sense. So the plus 02 means that it's the second declination bracket, so it's basically 2 degrees declination. And 2116 means that it's 2116th star, counting from 0 degrees right ascension. So yeah, you can actually figure out roughly where these things are in the sky based upon these numbers. Now, Bonn is in the northern hemisphere. There was a southern hemisphere equivalent, the Cordoba Durchmusterung, whatever, uses the same code numbers as well. And similarly, CPD minus 417712 is the Cape Photographic Durchmusterung. I'm sorry, I really don't speak German. CPC 206743 refers to the Cape Photographic Catalogue. CSI, in this case, doesn't refer to crime scene investigations. No, it refers to the Catalogue of Stellar Identifications. DEN is the Deep Near Infrared Survey. G12260 is part of the Lowell Proper Motion Survey. GCRV sounds like a ship class from a culture novel, but it in fact refers to the general catalogue of stellar radial velocities. HD is the Henry Draper catalogue. GSC comes from the Guide Star catalogue. HIP is the Hipparcos catalogue. This is the catalogue that was produced by the Hipparcos satellite, which very carefully measured parallaxes on thousands and thousands of stars. It was a comprehensive survey that got distances to many objects nearby. And related to this was TYC, which is the Tycho catalogue that was produced by the Hipparcos mission, which gave better positional data for a number of objects, even if it didn't have as good a parallax measures. HR is for the Harvard Revised Catalogue. KOI refers to Kepler Object of Interest. This is related to the Kepler spacecraft, which has been looking for planets or exoplanets orbiting stars. The KOI objects tend to be concentrated in specific regions of the sky because the field of view was fixed. LS521 is an example of a member of the Luminous Stars catalogue. MCC refers to the McCormick Observatory catalogue. PLX is the general catalogue of trigonometric stellar parallaxes. Parallax, by the way, is how much a star wobbles back and forth as viewed from the Earth, which is orbiting the Sun. It lets you figure out how far away they are. SDSS is a member of the Sloan Digital Sky Survey. Anything designated with XTE is part of the X-ray Timing Explorer catalogue. The PSR, by the way, is added to designate anything which is a pulsar. So that's probably a compact object emitting regular pulses of radio waves in the direction of Earth. Now, we've covered most of the major catalogues, but there are still a number of named objects in the game, which come from academic sources, but they're more like individual papers. This one, GMM 2009, is a reference to an academic paper published in 2009. It's a Spitzer survey of young stellar clusters within 1 kiloparsec of the Sun, and it's by Guttermuth, Megeith and Myers, amongst others. It's also interesting to note that this structure here is kind of a very strange shape. If I zoom out here, you'll see that it has a kind of weird linear feature to it, and that actually points towards the Sun. And the reason for this is that getting position on the sky accurately is very easy, but getting distance is a lot harder, so the error bars in this direction are really long. And I think this is probably a spherical cluster somewhere in this region, but the data makes it look like a much more sausage-shaped object. DM99 is a reference to a paper by Dolan and Matthew in 1999, which looked at pre-main sequence stars near Orion. PW 2010 is predictably a paper from 2010 by Povich and Whitney. They looked at star formation in one of the Messier objects, I believe. Anyway, there's plenty of these papers in here, and what you can really take away from this is that the game has actually looked at the latest in research, or at least it has downloaded the latest in research from catalogues everywhere. Okay, so with 400 billion star systems to name, basically they're going to run out of real names. They've run out of real names. They have to make up names for some of these things. They have a number of stars which get given names that are created by a name generator, and many of them are kind of interesting. Well, okay, so we have Yanka. Honestly, I would prefer that more of them were named like because that's really how I want to pronounce them. But these names tend to only get generated for stars which actually have people living around them. For the more, for stuff where people don't live, they get named according to sectors. For example, we have Alrai sector here, Col 285, a core Cis sector, which presumably is near to the core systems, Piscium sector. But yeah, Call 285 is interesting because I think that might actually be a reference to the Colander catalogue, which is a catalogue of clusters, I think. So if you look at many of the sector names, they tend to be associated with larger features or extended features in the universe or in the galaxy. For example, we have LBN 623 sector. LBN is Lynn's catalogue of bright nebula. IC 1396 comes from the Index catalogue. It's better known as the Elephant's Trunk Nebula. M7 sector covers the open cluster of Messier 7, also designated as NGC 6475. NGC 129, again that's the new general catalogue. It's a cluster in the constellation of Cassiopeia. It was discovered by Herschel. Mel 111 is a reference to the Melotte Deep Sky catalogue. This is better known as the Coma star cluster in Coma Berenices. Coma Berenices is one of the few constellations, I think it might be the only constellation named for a real person. Coma Berenices refers to the hair of I think it was a Queen Bernice, but I could be wrong on this. Anyway, again, it's just another sector name, and that really brings us to the end of this huge kind of look at this ginormous galaxy here. I've no idea how long it will take for people to explore everything in here, and it's going to be interesting because, of course, the developers are going to continue adding new stuff all the time, new things to see, new places to be, new things to explore. But I hope you found this interesting. Until the next time, I'm Scott Manley. Fly safe.